Hi, welcome to my video on the review of related rate word problems. And as in all my reviews, this one is going to be marked at a 40. So you give a score for each question, total up the scores on each page, and hopefully you'll have 40 out of 40 when you're finished. So here we go. Number 1, find df/dt in terms of A if f equals half A, B, C, B is 12A, C is 2/3 A. So that means we have to have B and C in terms of A. So F equals half A, B is 12A, C is 2/3 A. So F is equal to, and 2 into 12 goes 6. 3 into 6 goes 2, so 2 times 2 is 4. A times A times A is A cubed, and we get df dt. 4 times 3 is 12. The 3 decreases by 1, and we get dA dt. So it's 2 marks for that. So 1 for that step, and 1 for that step by substituting. We have the answer here, so 2 marks. The side of a cube increases 2 centimeters a minute. Find the rate of change in the volume when the side is 4 centimeters. So we have a cube, and a cube is like a sugar cube, and a cube has all sides the same, so we can have an S and an S and an S. So the volume is LWH. So the volume is S times S times S. So the volume of a cube is S cubed. So we do dV dt, and 3 times 1 is 3. The 3 is decreased by 1 to give me 2, so that's ds dt. So we get a 3, and it says that the side is 4, so we get 4 squared. And ds dt is 2. So that gives us 3 times 16 times 2. And 6 times 16 is 96. And it's a volume we got to find. So it's cubic centimeters in terms of time is in minutes. So there's 3 marks there. So if you have the equation, you have the derivative, and you have this answer, you get 3 marks. And we have another one, number 3. A rectangular box has a square base. So let's just draw that for a second. A rectangular box is just like a cube, only it's a rectangular shape. It has a square base, so let's let the base be x, and we have a height. The surface area, so let's write down what we're given. Keep track of everything. So we got a given. We have a surface area increases at a rate of 120 square feet per second. The edge of the base increases 2 feet per second. Find how fast the height changes when the base edge is 8 and the height is 2. So we're given a rate, the surface area, I'm going to call surface area SA dt. DSA dt is 120 square feet per second. And the edge of the base increases at 2 feet per second. So it's dx dt is 2 feet per second. And we have, we want to find the rate of change in the height when the base edge, so the base edge is x, so x is 6 feet. And the height, which we call h, is 2 feet. So we have to find, it says, right down the givens, we're going to find how fast the height is changing. So it's dh dt. That's what we have to find. So the surface area, what is the surface area? So the surface area of this box is, the bottom of the box is a square and the top of the box is a square. So the square is S squared is the area of a square, and there's two of them. And each of the sides is x times h, but there's four of them. So it's one front, right here on the side, and this one is the same. All these side faces here are all the same, so it's 4xh. So we have the derivative of surface area, so it's dsa equals dsa dt, and derivative of 2x squared in relation to t, 2 times 2 is 4, x decreases, 2 decreases by 1, and we get dx dt. Now we have a product here, so this is f, and this is g, so 4x is df, so derivative of 4x is 4 dx dt times h plus f, which is 4x, times the derivative of h, which is 1 dh dt. So now we have the derivative done, we do a substitution. So we have the surface area is changing at 120, so that's 120. 4, x is 6, dx dt is 2, 4, dx dt is make sure, is 2, yep, 4 times 2, yeah, dx, yeah, look what I said, I know, I wrote down 2 here, but it's not, it's supposed to be 3, so that's a 3, and there's a 3 there, and the height is 2, so just a little, I just looked at it, said a 3, but wrote down a 2 here, and I do those a little, what I call silly errors occasionally. So x is 6, and we got to find dh dt. So that's a 120, and that's 12 times 6 is 72. 12 times 2 is 24, and 4 times 6 is 24 dh dt. So it's 120. That makes it 96 plus 24 dh dt. And that gives us, make sure here, and just save a little, space is running out, 120 minus 96 is 24, so it's 24 equals 24 dh dt. And divide by 24, so dh dt, 24 divided by 24 is 1, and that's the height, and the height is in terms of feet, so it's 1 foot, and the time is in seconds. And if you have that answer, you get 5 marks, but we break it down, and that if you have this formula for the surface area, you get 1 mark. If you did the derivative right, I get 2 marks because I did the product is an extra mark here for the product. And if you substituted it in correctly, you got another mark. And if you did the final answer is 1 foot per second, you got another mark, so 5 marks altogether. Total up a page, and you have hopefully 10 out of 10. Let's continue. Number 4, a survey is forming a sand pile on the ground in the shape of a cone, where the radius of the base is 3 times the height. The height is increasing at a rate of 2 meters a minute. Find the rate of change in the volume of the pile when the height is 4 meters. So let's draw a little diagram here. We have a pile that's forming a cone. So let's draw a cone. It's coming down and forming a cone. So here's the cone like this, forming this cone on the ground. And it has a radius, which is here, and it has a height, which is here. So it says it's forming a cone, so let's see what we have given in our problem. It's forming a cone where the radius of the base, so the radius is 3 times the height. Okay, the radius is 3 times the height, and the height is increasing at a rate of 2 meters per minute. So dh dt is 2 meters per minute, and we have a height of 4 meters, and we have the find. It says we're going to find the rate of change in the volume, so dv dt of the cone. So what's the formula for the volume of a cone? V equals 1/3 pi r squared h. The volume of a cone is 1/3 the volume of a rectangular, 1/3 the volume of a cylinder. So if we take a cylinder and split it into a cone shape, it goes 1/3. So what we have here, it says we have the radius is 1/3 the height. Notice this is in terms of height, and this is height. So let's substitute 3h for r. So we have all heights. So the volume is 1/3 pi times 9 h squared times h. So the volume, 1/3 of 9 is 3 pi h cubed. And we're going to find dv dt. So d dt on the volume is dv dt. 3 pi is a constant, and the derivative of h cubed is 3h squared dh dt. So that becomes 9 8 pi h squared dh dt. Simplify that, and now we want to get substitute in for h and dh. So we got 9 pi. So h is 4, and dh dt is 2. So that's squared there. So that's 9 pi. 4 squared, we do PEMDAS, we do the square first. So we squared 4 to get 16. So 18 times 16 is 288. And as the volume, so it's cubic meters in terms of time. So it's 288 cubic meters a second. And I gave 4 marks for this question. So if you came up with the formula for a cone, volume of a cone, I gave you 1 mark. If you came up with the substitution here and worked it out, I gave you another mark. If you did your derivative okay and you came up with this equation, I gave you another mark. And if you put the 4 in and worked it out, you got 288 cubic meters a minute. Then I gave you another mark, so that's 4 marks for that question. Let's continue. Now I try to do a variety when I do a review. Just help explain what's happening. So a variety is, let's go with another one, number 5. A boat is being pulled into a wharf by a rope attached to a pulley at the top of the pole and to the top of the bow on the boat. The bow of the boat is 3 meters above the water. The pulley is 13 meters above the water. The rope is pulled in at a rate of 2 feet per second. How fast is the boat moving when the rope is 26 feet long? Well, what I like to do here is draw the diagram, because it'll give me let's say we have, this is the water, and we have a boat in the water. So there's the boat that's in the water. And we have a wharf, and there's the wharf is with the pole on it. So here's the pole, here's the pulley up at the top of the pole, and we have a wharf here. So the rope is attached to the pulley to the bow of the boat. The bow of the boat is right here. So it says that we have the pulley is 13 feet above the water. So this is 13 feet from here to here. The boat is 3 high, so that means that you got a 3 here, so that means the length of the pole is 10. So what we have is we have 10 feet from here to here, so there's your perpendicular, and we have, let's label this as X, let's label this as the rope, and this is the height of the pole right here. Notice the height of the pole is not changing. The height of the pole never changes. It's the rope that changes and the distance the boat is moving. So let's mark down what the given is. Again, I'll draw the diagram. So the given is we have the height of the boat is 3 feet out of the water. And we have the height of the pole is 13 feet. And the rope is being pulled in at a rate of 2 feet per second. So it's dr dt. So it's, when it's pulled in, rope is getting shorter. So that's a minus 2 feet per second. That's the speed. Because as the rope is being pulled in, the boat is going along horizontally like this. And this is the horizontal distance. So we have, and the rope is going to be 26 meters long, 26 feet long, sorry. So what do we have to find? How fast the boat is moving. So that's dx dt. How fast the boat is moving is the horizontal speed going from here to here. So what we have a right triangle, so we have c squared is equal to a squared plus b squared. So what we have are the rope, the length of the rope, and we have the 10 squared, and we have the x being squared. So that allows us, if we want, we can say when the rope is 26, so we can go 26, 10, and that will give us the distance that the boat is going to be pulled through. So 26 squared is 676. That's 100. That's x squared. So when we subtract 100, we get 576 is x squared. So x is equal to plus or minus the square root of 576. X is equal to plus or minus 24. So x is positive, so it's 24. So this is 24 here. But we have to do the derivative. So we got an equation here. So we have r squared, and this is the height. So it's the height, and x. So instead of putting a 10 in, I'm going to leave the variable of the height in place of the 10 and do the derivative in terms of these variables. So d dt on r squared is 2r dr dt. Derivative of h in terms of t is 2h dh dt. And the derivative of x squared in terms of t is 2x dx dt. So if we want to find what dx dt is, so 2r is 26, and dr dt is a minus 2. 2h, the height, is 10, and dh dt is constant, so that's a 0. And we got 2, x is 24, and we got to find what dx dt is. So 2 times 26 times negative 2 is a negative 104. 20 times 0 is 0. 2 times 24 is 48 dx dt. So we got a negative 104 equals 48 dx dt. Divide negative 104 divided by 48 dx dt. So dx dt. And if these are even, so I just take my time and reduce that down. So that's 2 into both of these gives me 52 over 24. Again, they're even, so it's negative 26 over 12. They're still even, so it's a negative 13 over 6. So this becomes a negative 13 over 6. And that's the speed, so it's feet per, let's see, was it moving? Feet per second. Okay. And the negative indicates that it's being pulled in towards the distance is getting shorter. So the speed of the boat is 13 over 6 feet per second. And the negative only indicates that it's going towards 0 distance and 0 speed. And that's 6 marks for that. So if you came up with the 10, you got a mark. If you came up with the 24, right here, you got another mark. If you came up with the formula here, you got another mark. If you did the derivative correctly, you got another mark. If you substituted in, another mark. And if you worked out the negative 13 over 6, you got another mark. So that's 6 marks altogether. And that's the allocations. And again, as I said, I'm going to review the units. So I'm going to do as many problems as I can. And in this problem, I have 8 done. Number 6, a person 5 feet tall is walking away from a streetlight, which is 15 feet high, and walking away at a rate of 6 feet per second. At what rate is the length of the person's shadow changing? So, again, let's draw a little diagram. Again, I'm a habit of drawing diagrams first and then fitting in the information. So we have a pole, street light, there it is, and the street light is perpendicular to the ground, and a person is walking, which is also, again, the person is perpendicular to the ground. The person is 5 tall, and the street light is 15 feet tall, and the person is walking away. So what I'm going to do is the distance the person is walking is this distance. The length of the shadow is this distance. So there's the distance the person is walking, and this is the distance that the shadow is passing through. So what we have, again, we have a given. Let's look at what we're given. We're given, let's see, the height of P. Height of the person is 5. The height of the, let's call it light, or street light, let's call it L. The height of the light is 15. And the speed of the person, D, is, let's let the speed of the person be y. Let's call that a y there. This is the person's walking, so it's dy dt. And the speed is 6 feet per second. And so what are we trying to find? We're trying to find the length of the shadow, and the shadow length is x, so it's dx dt. What we have is, as I've shown you before when we did the previous videos, we have similar triangles, 2 right triangles. That's 15, and that's the height of the pole, height of the person. And this is the shadow here that the person is casting. And right here we have a y plus an x. So the total distance is add the distance the person walks to the length of the shadow, which is x. So we have similar triangles. That means we have a ratio 15 over 5. So is y plus x over x. So when triangles are similar, the ratio of the sides is equal. So that means that we have 15x is equal to 5 times y plus x. 15x equals 5y plus 5x. Bring the x over here, gives me a negative 5, so it's 10x equals 5y. So that means 2x equals y. So y is twice x. So if we do the derivative here in d dt, we will get 2 dx dt. Derivative of y is 1, so we get a dy dt. So what we have is, we have 2 dx. We have divine, again, look what I did. Dx dt, dx dt, that's a t here. You have to be careful. So dx dt. So dy dt is 6. So that means dx dt, 2 and the 6 goes 3. So we have, again, the rate is 6 feet per second. So we had to use similar triangles to show this relationship. And there's 5 feet per second is the correct answer. And there's 5 marks. So if you did the triangle correctly, I gave you a mark. If you did the ratio here, I gave you a mark. If you solved it out, 2x, right here, I gave you a mark. If you did the derivative correctly, I gave you a mark. And if you did substitute 6 in, I got the 3 feet per second to give you another mark. So 5 marks altogether. Hopefully everything is going okay. We got a couple more problems to do, and then we're finished with this unit and finished with related rates. Number 7. 2 walking paths are perpendicular to each other. At the point of intersection, a boy walks away on one of the paths at a rate of 30 meters a minute. A girl on the other path, 180 meters from the point of intersection, walks at 50 meters per minute towards the intersection. How fast is the distance between them changing when each leave at the same time and walk for 2 hours? And again, what I like to do is that I like, in this case, to draw a diagram. With the diagram, then I write down my givens. So what I have is 2 paths are, there they are, 2 paths are, walking paths are perpendicular to each other. So it says that the boy walks away on one of the paths. So let's put the boy right here, and the boy is walking away this way. Okay, and the girl is on the other path. So this is the girl is on the other path, 180 meters away, and the girl is going to walk this way. So there's the 180 there, and the girl is going to walk towards the point of intersection. And this is the girl, 180 meters away. So let's see what we're given. Let's see. We have the boy is walking at a rate of 30. The boy is walking away as the distance is increasing. So dB dt is 30 meters a minute. And again, I indicate that's a plus because it's walking away, distance is getting larger. And the girl, g dg dt, is, the girl is 50 meters, but it's a minus 50 meters a minute because the girl is walking back towards the point of intersection, whose distance is getting shorter, so it's a negative. And they're both walking for 2 hours. And the girl is 180 meters away. So, so that means if the girl is 180 meters away, let's see, we gotta find. So after a certain period of time, the girl is walking in here, and the boy is walking out here. So let's draw this right triangle. So the girl is leaving here and coming in. So at this point in time, right here, after 2 hours, the girl is right here, and let's say 2 hours, the boy is right here. So what we have is we got a distance equals rate times time. So the boy is walking at 30 meters per minute for 30 meters. Oh, 30 meters per minute. Oh, I didn't want to have minutes and hours, and because it wouldn't work. So one little mistake on my part is that I should have 2 minutes. I didn't want to walk for 2 hours. If you walk for 2 hours at 8 right here, the girl would be here. You imagine that would be 2 hours is 120 minutes. Walking for 120 minutes times 50, definitely the girl would be here in a short period of time. So my mistake, this is out at 2 minutes here, walking for 2 minutes. So that's 2 minutes, so that makes it 60. And so the girl is walking at 50 for 2 minutes, so that's 100. So that's 100 meters, 100 meters. So the girl is 180 meters away, walking for 2 minutes, which is 100. So the girl is at 80 meters. So this is 80 meters here for the girl, and the boy is at 60 meters away. So there's 6, oops, make that a 6. So the girl left here, walked in here, is 80 meters away, and the boy is 60. So this is the distance that they are apart. So if that be the case, so we got, the distance d, so we got d squared is a squared plus b squared. So d squared is 60 squared plus 80 squared, 3,600. And 80 squared is 6,400. That's 10,000. So d is plus or minus the square root of 10,000 plus or minus square root of 10,000, 100. So the distance is 100. So this all happens when they are 100 meters apart. So if we got d, and we said A and B here, but again, it don't make any difference if I use A and B. But let's change this to the this make B be the boy and G be the girl. Same thing. Just change the variables. So G is the girl squared, B is the boy squared. So when we do d dt, which we have to, oh, I didn't write down what we got to find. Oh, we got to find the distance between them. So it's d dt, d dd dt. So we got to find the distance, how fast the distance is changing. So d dt and d squared is 2d dd dt. Derivative here in terms of t is 2g dg dt, and the boy is 2b db dt. So let's fill in the information. So the distance is d is 100, and we got dd dt, which is what we got to find. 2g, g is the girl, and the girl is 80, and the speed of the girl, how fast the girl is walking, is a negative 50. and the boy is 60, and this, how fast the boy is walking is 30. So we have all that filled in. And so that gives us 200 dt, and that's a negative. That's 100 times 80, so it's a negative 8,000. And that's 60 times 60 is 3,600. So it gives us 200 dt. That gives us a negative 4400. When we subtract, 36 from 80 is 44. And we divide, dt is negative 4,400 divided by 200 is a negative 22 meters a minute. Time is changing in terms of minutes. Remember, I made a mistake in terms of hours here. So it's meters per second. So if you have a negative 22, your answer is perfect. But I give extra marks. So if you did your distances and you got your 80, there's 2 marks. If you did the distance of 100, I gave you another mark. If you wrote down the equation, which is the Pythagorean, I gave you a mark. If you did the derivative, I gave you a mark. If you substituted in correctly, I gave you a mark. If you got this answer, I gave you a mark. So 8 marks altogether. So one more question and a review of related word problems will be done. And again, I wanted to make an example of each one. A person walks along a straight path at 4 feet per second. A searchlight is located on the ground 20 feet from the path and is turning to keep shining on the person. At what rate is the light rotating when the person is 15 feet from the starting point on the path, which is perpendicular to the distance from the light? So this person is 15 feet and the starting point is perpendicular to the light. So what we have again, if you think about it, we have a path, there's the path, and this is the light. The light is on the ground this time, not up in the air. So I'm drawing it so you can think of it as there's the person walking, and it says that the light is rotating, so that means as the person is walking along here, this light is following him. So the light is turning like this. So let's call this angle here that the light is rotating through theta, and let's call the distance that the light, there's the walking path, so let's make a right angle here and call this y and call that x. So what we have is, let's write down the given. I like to draw the diagram with the x's and y's and theta and that, so that when I write down the given we can see what's happening. So it says that it's dx is how fast a person is walking. So dx dt is person is walking at a rate of 4 feet per second. And the light is 20 feet from the path, so y is equal to 20 feet. This distance here is 20. And we also have that the distance that the person is walking is 15 feet. And now you can see why I call this x, I call this y, because now I can, instead of saying the vertical distance and the horizontal distance, and this is the angle that's doing the rotation. So that's the given. So what do we have to find? We have to find how fast the angle is changing. So d theta dt. So there's the angle. So as the person moves along here, the light is moving along with him. So this is the angle of rotation. So what we have again two sides. So let's get the third side. So we got c squared equals a squared plus b squared. So this is the distance from the light to when the person stops. So it's d squared is x squared plus y squared. And we have the distance, d squared, and we have x is 15 squared, y is 20 being squared. So 15 squared is 225, 20 squared is 400. So d squared is 625 when you add them up. So d is plus or minus the square root of 625. D is plus or minus square root of 625 is 25. So d is 25. Okay, now we have to, so we have an angle. So because we have an angle, we have to use trig. So that means we have to use in relation, notice we have in relation to x is the rotation of y. So this is the tan of theta is opposite, which is the x over the y. So that means that the tan of theta, I could use f and g as in a division, but let's use f y to the negative 1 and use a product of f and g. So we have to do the derivative. So the derivative of tan is secant squared d theta dt. And we have derivative of x is 1, so it's dx dt, y negative 1. And we have f and g, so f is x. Derivative of y to the negative 1 is negative 1. And negative 1 becomes, subtract 1 is negative 2. And we got dy dt. So that's the derivative. So we have a 25 here, just to put that in. So we have a secant squared here. So the secant is the reciprocal of cos. So the cos of theta, here's theta, cos is the adjacent over the hypotenuse. So that's cos is the adjacent, which is 20, over the hypotenuse, which is 25. 5 into 20 goes 4, 5 into 25 goes 5. So if cos theta is 4 over 5, that means secant is the reciprocal. So secant theta is 5 over 4. So now, do we have everything? Let's check. We'll find out. Secant squared is 5 over 4 being squared. D theta dt. Dx is 4. Dx dt is 4. And this is y to the negative 1. So we have, that's 20 to the negative 1 plus x is 15. And we have negative y, which is 20. So it's a negative 20 to the negative 2. And dy dx is, again, this height of 20 is not changing. 20 is fixed. The height of the light is constant, so that's a 0. So we have 25 over 16 d theta dt. And this 20 to the negative 1 is 1 over 20, so that's 4 over 20. And that's a 0 here. No matter what, this works out to be 0 times these two products is 0. And so what we have is d squared d theta dt is 4 over 20 is 1 over 5. We can reduce that. Now, when we divide here, we multiply by the reciprocal, so that becomes 16 over 25. Again, you can multiply both sides by 16 over 25. 16 over 25. This cancels out to give you a 1. And so we simplify this. So d theta dt is 16 over 125. And the angle rotates in terms of radian. So this is 16 over 25 radians. And the time is in, what's the rotation? Per second. So that's per second. Again, the angle of rotation is in terms of radians. You could take your radian and change it to how many degrees it's rotating. So the light will be rotating so many degrees a second, but they always express it in terms of radian. And there's 7 marks for this question. So again, if you drew your diagram, which is important, I gave you a mark. If you did this trig ratio here, I gave you a mark. If you worked out 25, I gave you a mark. If you worked out this secant, I gave you a mark. And if you did the derivative correctly, I gave you a mark. And you worked all this out and got the right answer, I gave you a mark. And where else? Oh, and you did your Pythagorean, which is important to get to 25. I gave you marks. So 7 marks altogether. So hopefully everything has gone well. And that leads us total of all your, go back to the main sheet now. Total of all your pages and your markers at a 40. So divide 40 into your numerator, get a decimal, move it 2 places to the right to get your percent. And hopefully you got 100%. If you didn't, look up your error, see where you went wrong. And again, this is the last video on this unit of related rates. But it's not the last video that I'm going to have in my website. I'm going to do more review of the content from grade 6 or 7 on up to Calculus 1. And if you like my video, click on it. If you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.